Welcome again to 10 Minutes with Harry. Today I'm going to look at what I call SVE Pairs. This Holter monitor recording was taken a short while ago, and in a period of 7 hours, there were 2 instances seen where there appears to be SVE pairs. And you can see on the top, red highlight, and on the yellow highlight, looking very similar. But are they? In order to understand what is going on, we need to re-look at an atrial ectopic. An atrial ectopic has a premature P wave, a QRS, which is identical or near identical to the sinus QRS, and there is a compensatory pause. 2 consecutive atrial ectopics are called a couplet, and this is a common cause of SVEs. Here is another example of an atrial couplet, but it is not premature, but rather the second atrial ectopic, which is a low atrial ectopic, occurs well away from the first. I'd like to now briefly cover what I call the compensatory pause. One can see here in red highlight an atrial ectopic with a pause, and this is called a full compensatory pause. To explain, we have a look at the P waves in the red vertical arrows, and there is one vertical arrow not there. It's hidden. So it is a non-conducted sinus beat, and it is concealed. A full compensatory pause means that the 2 sinus cycles with the embedded atrial ectopic is exactly the same as 2 sinus cycles without the atrial ectopic. The other type of compensatory pause is a partial one. Once again, you can see an atrial ectopic looks very similar to the one above. And again, we highlight the P waves with the red vertical arrows. Now, where is the hidden one? Well, it's not actually hidden. It lies outside the T wave and it's not there. This is because there is no P wave, but rather that the atrial ectopic has depolarized the ventricle and then by retrograde conduction gone back and reset the sinus node. In doing so, the next beat occurs here with the stippled red arrow, and then the timing now means that the 2 sinus cycles with the embedded atrial ectopic is shorter than the 2 sinus cycles without an embedded ectopic, and hence the term partial. Here is another SVE, 2 SVEs here. It looks like it, but when one looks more carefully, you can see that the yellow highlighted SVE is actually a sinus beat with a P wave, and that the red embedded is an actually interpolated atrial ectopic. So this we call interpolated, which means no compensatory pause. To explain, here we have an interpolated atrial ectopic in this first degree block here, and we can see the atrial ectopic in the red highlight and no compensatory pause. There is a P wave present in the T wave, and there is PR prolongation even further because conduction is partially refractory. Also note that the QRS has aberration, which we have discussed previously. In comparison, the atrial ectopic with the compensatory pause on the right, yellow highlight, now it has a compensatory pause. The reason for the difference between the two lies in the timing. To the left, the interpolated atrial ectopic occurs earlier for 60 milliseconds, giving plenty of time for the next sinus P wave, which is embedded in the T, to actually conduct, albeit with some refractory and therefore slower. Whereas to the right, where it is a normal compensatory pause, the atrial ectopic is later. And therefore, when the P wave occurs, it occurs within the QRS and therefore is totally refractory. No aberration is noted because it is later. Here is another one. And you can see now there is a difference in that the P to P interval with what appears to be an interpolated atrial ectopic with aberration is actually not interpolated because the P to P interval is shorter than the normal sinus cycle length. And if you look carefully, you can see an echo beat, and that echo beat means that the atrial ectopic has conducted to the ventricle, then by retrograde conduction goes back to the atrium, and this then passes anterograde again and depolarizes the ventricle through the conducting system. These are called echo beats. And finally, look at this so-called couplet. There is, in fact, the beat before, in blue highlight, is an atrial fusion beat. It's an amalgam between the sinus beat and the atrial ectopic, both occurring virtually at the same time and therefore both contributing to the depolarization of the atrium. An atrial fusion beat. So if that's the case, this is an atrial triplet, and you can see that where the red arrow occurs within the fusion beat, the sinus beat starts later, and it is the atrial ectopic that's earlier, and the two of them fuse together. Both contribute toward atrial depolarization. And finally, this appearance here, you can see, is that there are two atrial ectopics. The first blue arrow, you can see first degree AV block, and the second one with the stipple blue arrow, there is no conduction. So this is in fact a Wenckebach second degree AV block within an atrial couplet. Now let's go back to our two tracings and see what we can make of them now. Above the red highlight, we can see that the timing suggests that here we have an interpolated atrial ectopic. Below, one can see the atrial fusion beat, and therefore there are three atrial ectopics, or a triplet. And the timing again suggests that it is the ectopic that starts to depolarize the atrium first, then followed by the sinus node, and it causes fusion. Therefore, neither of these tracings, in fact, show an atrial couplet, but two different types or forms of supraventricular ectopy. Thank you.